By experiencing geometric transformations as functions, students can engage in sensory-motor experiences that shed a powerful light on important mathematical concepts. This movie illustrates the first 6 elements of the mathematical foundation underlying this geometric functions approach. First, when students create and experience functions in the realm of geometry, those functions don't have numeric variables and aren't defined by an algebraic formula. Construct an input point and a mirror. Then reflect the input point across the mirror. Because there's only a single reflected image for any given input point, reflection is a function that takes the red point as input and produces the blue point as output. Second, variation is kinesthetic and visual. Just grab the variable and move it around. Turn on tracing and drag again to see a picture of how the variables have varied. In a sense, this picture is like a table of numeric values, but containing far more values and revealing the function's behavior in a visual way. Third, by dragging the variables, students experience variation as continuous motion and can later extend this idea to dragging a numeric variable on a Cartesian coordinate system. Fourth, students can create function notation as an abbreviation describing the output variable. Use the text tool to label the input variable x and label the mirror j. Then label the dependent variable as the reflection r across mirror j of independent variable x. By describing the function, this notation actually makes sense. Fifth, students can construct a shape and restrict the domain of the input variable by merging the point to the shape. By dragging x along this restricted domain, they experience the process of transforming not just a single point, but an entire domain. In this case, the set of points that makes up the polygon. Sixth, students can experience function behavior by playing the role of the dependent variable. In this game, I'm the blue dependent variable. My job is to be the reflection of the independent variable z. The crosshairs show me the point whose reflection I am right now. And when I'm in the correct position to be the dependent variable, the polygon turns green. I have 3 seconds until z starts moving at a constant speed on its restricted domain. Go. As you do this dance, you'll notice that the variables move at the same speed, but sometimes in the same direction, sometimes in opposite directions, and sometimes in between. So these are the first 6 elements of the mathematical foundation underlying the geometric functions approach.